But I am going to talk about technology for sure, being in a technology business. And you know, we are in a technology revolution today. And the effect that the technology is having on our lives is profound, and it's only going to increase. And you know, there's a lot of technology companies, startups as well as large corporations here in Austin, and you can see technology developments here that are happening that are impacting the entire world and will continue to do so. So today what I want to talk about is really three things. One, I want to talk about something that's a very big challenge, which is the global economy, that Miney already told us a little bit about, clearly affecting us. Secondly, I want to talk about something very exciting, which is technology today and some of the developments that I see that will impact our future. And third, talk about something fun, which is bringing more talent into our science and technology curriculum. So, first of all, you may not know very much about Emerson, so let me spend 1 minute on this, or less. We are a $25 billion global corporation, a diversified global manufacturing, engineering, and technology company. Our headquarters is based in St. Louis, our corporate headquarters. We're about 115,000 employees worldwide. We are celebrating our 125th anniversary this year, and we are passionate about innovation. And what we basically do is we make the instrumentation and control software that actually controls and optimizes much of the world's critical infrastructure. So oil and gas production, refining, power plants, chemical plants, life sciences industry. You know, first of all, we make the smart sensors, or the nerves that are out there in those plants that measure pressure, temperature, level, flow, composition, those sorts of things. Secondly, we make the software that scans thousands of points every second, runs thousands of algorithms. It's really the brains, if you say, of a refinery or of a chemical plant or an oil production facility. And third, we then exercise the muscle, or the final control valve that actually manipulates the flow in a pipeline to control a particular facility. So we're not in discrete manufacturing. We really are all about process. So you think about it this way. If it flows through a pipe, we're there. And we're very committed to Texas. In fact, we have 5 different businesses. Their global headquarters are in Texas, 3 in Houston, 1 in Dallas. And the largest one actually here in Austin, our Process Systems and Solutions business, is based here. You can see we have about 850 people here in Austin, highly degreed workforce, engineering, a lot of software capabilities. And I always say that our brain trust for this business worldwide resides here in Austin. Our prolific inventors are here. A core part of our software development. We have about 200 software developers here. And so what we develop here truly changes the world of process automation around the globe. And we feed that technology out to more than 10,000 of our employees worldwide to apply and service that software technology. We've been in Austin since 1981, was when we came and established our first operation in Austin. And recently, as Pat said, a couple years ago, we opened and dedicated a $70 million investment here for an innovation center up on Highway 45. You probably see it as you pass up there in Round Rock. Now, I could give Mina's talk all over again, because while my technology pool and my technology resources run on an Austin economy, my business really runs on a global economy. And we have 2/3 of our businesses outside the U.S., and so we're heavily impacted by all the dynamics that Mina talked about just a moment ago. So price of oil down has really squashed capital spending as well as even MRO spending in our particular industries. The strengthening U.S. dollar has put us at a competitive disadvantage against many of our large European competitors. We compete against ABB, Siemens, Schneider, some of those kinds of people in Europe on a global basis. And of course, slowdown in China has also hurt us. We're heavily invested in China. In fact, outside the U.S., that's my largest market for our products and technologies is China. So we'll talk more about this, I'm sure, in the panel. But in fact, you know, it's tough to have a global economy like that. It's clearly made us some challenges this year as we've continued to try to invest and drive our technology business worldwide. So let's talk about technology a little bit. And I want you to just think for a minute. We're going to look in the rear view mirror of technology for just a moment here and think about the impact that technology has on your lives over the past 20, 10, 5, whatever years. So think about computer technology, the way that's advanced over the last 25 years. Think about the internet technology and how that's changed your lives and changed how you do things, how you interact with people and companies and data. And think about mobility and mobile devices, your smartphones and things, and how that's changed how you act and how you behave. Well, you know, I talked about the energy industry and the oil and gas production what's happening in the oil pricing. I would tell you the genesis of that is actually driven by technology. And it was really the convergence of three technologies that came together. That would be 3D seismic analysis, it would be horizontal drilling, and the fracking technologies. As you put those three together, it created an enormous energy boom in the United States in shale gas and producing shale liquids. And so that created an oversupply globally, created a price drop, strengthening the dollar, and so that is what's happened to us in the oil industry. It came really honestly from technology drivers. But what the good news is with that feedstock, that low feedstock of gas and oil price now, it's feeding a investment wave in the downstream business in North America, particularly on the Gulf Coast here. And you can see now things like we're converting our power plants, our electric generating power plants to gas, not coal anymore. We're taking coal offline. We're now building liquefaction plants to liquefy our cheap gas, to export it. So we're turning import terminals into export terminals with liquefaction trains. And third, we're seeing a huge boom in downstream ethane crackers, ethylene crackers, that sort of thing, to develop petrochemicals out of the cheap gas. So you can see a huge investment wave is coming on the Gulf Coast. This is going to drive for Texas a shortage of that kind of labor to actually drive a lot of that production capacity and build those plants in Texas. So that's the good news on the oil price. You feel it as a plump, it goes down. That's a good thing. For some companies it hurts us, but again, there's others that benefit in a downstream way. So now I want to talk about the future of technology. And okay, is there another inflection point like we just saw in the oil and gas business coming? And I will say absolutely. And there will continue to be. And I could talk about a lot of different technology areas that we're working in that we see these inflection points, but I want to talk about, again, one of these where we see multiple technologies coming together to create another inflection point here. It's happening, it started to happen, it will continue to happen, and that's right here. It's the connection of smart devices, it's mobility combined, and then it's cybersecurity. So we put these three very software-oriented technologies together, and that's what we have. So, well, what is this Internet of Things that I hear a lot about? So that is really the evolution of products to being smart devices connected in a larger system and ability to communicate with each other. So, for example, in your home, your home thermostat will become more and more intelligent, communicate with other systems in your house, and talk to the manufacturers or service providers of those systems. In industrial and smart industrial machines will communicate with each other to optimize and organize work in a factory without human intervention. Or your car will become more and more intelligent so that it will measure its condition and its environment and will achieve real-time downloads from the manufacturer to optimize its performance. So lots of smart things talking to each other. These all have three things in common on top of the product itself. The first is it has smart sensors. It has embedded microprocessors and software that make the thing smart. Secondly, it has connectivity components in it that make it communicate and help it communicate with other smart things. And third, it has software on top that literally collects the data, aggregates it, analyzes it, and presents it somehow as information, now useful information to the users. So how big a deal is the Internet of Things? I'm telling you it's very big. So the first wave of Internet, was really all about people connecting to people. And so think about the evolution of that, Facebook and Instagram and all the things that we have there today, or connecting people with companies, the kinds of changes that drove, the kinds of companies that came up, Facebook, and made huge companies out of just an idea. Okay, that's happened to us in the first wave of Internet. The second wave now of the Internet, in my view, will be connecting things to things, and machines to machines, and machines to people. And so last night I actually checked on the Internet. As of last night, there were 3,206,000,000 people in the world that had a connection to the Internet. By 2020, the estimates are there'll be over 50 billion things connected in the Internet of Things. And so you will see this will have a profound impact not only on you as a user and the products and the things that you use every day, but also in companies and the opportunities and the growth of those companies. So for example, for you, what will happen here for you? Well, you will have smart devices all around you that continually are acting and you don't even know it. And you will lose the ability to go to your boss and say, I have to go home and fix my air conditioner broke, because your air conditioner knew it was going to break days or weeks in advance, and it probably already called the technician, and he's probably on all his ways to fix it. So those are the kinds of things, your cars, all kinds of devices around you will become smart. And when you think about the implication on businesses and the opportunity there, this would create enormous opportunities, not only for large companies like an Emerson or a GE or a Cisco to create the software and the smart devices there, but also new entrants. In fact, just this week, for example, Salesforce.com announced that they were going to get into the Internet of Things. They were going to create in their cloud software that allow you to connect these smart devices together. But also will be small new entrants you haven't even heard of yet and haven't even been conceived yet. So Millie, here's a great opportunity for you to think about new incubators and new areas in this area of data management and smart things. And I will also tell you that any product manufacturer today that just makes a dumb product is going to have to figure out how to play in this new world, or he's not going to be around very long. And so he has to move himself from a product design, product manufacturer, to also a software company to play in this new space. Now, I see two speed bumps on the road to utopia here. The first one is cybersecurity, because the more open I become and the more devices I communicate with, the more I'm at risk of being hacked. And of course, we can't have people hacking into critical infrastructure and create havoc and actually catastrophic situations. So that's a critical speed bump and issue that we must solve. The second is a skill issue. This is going to create more and more demand for software, technology workers as we create this world of smart things. So what does that mean for Austin? So we actually have been in this Internet of Things, we didn't know that's what it was called, for 20 years. We launched 20 years ago an architecture within our business that was called Plant Web. It actually embedded intelligence in all of our field devices, our sensors and our valves, and we created software that actually was able to take that data and use it to actually diagnose and interpret and anticipate failures in the condition of the plant and the equipment in the plant around it. And here actually there's a picture from our innovation center up in Round Rock, and you can see there we built a little process skid, a bunch of smart devices and smart pumps and motors and smart tanks that we literally can demonstrate and test and use this software to work on. And actually we also have software there that we can push that data out to also people around the world now. We really have now expertise without borders. We can move data to the people, to the experts, for them to analyze and diagnose problems. The next generation we're now launching will do another thing. It will move from the Internet of our things to the Internet of all plant things. And so we'll put more and more sensors on more and more of the machines and the equipment in the plant, and we're adding mobility, which will literally now let an operator or a maintenance person walk around a plant with mobile devices or wearable mobile technology, and the machines and the devices will literally start talking to the person in the plant. So great advances in the process management and process business. But what I will tell you now, the second speed bump is critical to us. So as my brain trust and technology organization sits here in the Austin region, I've got to continue to feed more and more software and more talent and capability. And we have, quite frankly, in the technology sector, an imbalance. We have a supply growing, or a demand growing, and we have a supply gap in these technology workers, particularly in the software development area, and you can see some of the statistics here. I think these may even be understated a little bit, and so we have a cost of talent going up. And we've worked with University of Texas here, A&M, the universities, but we love the product, we love the engineering talent that comes out of these schools. We just frankly don't have enough for the demand and as it continues to grow. And so our choice then is either to import it or to offshore it, and we really want to keep it right here at home in Austin. So what are we doing about that? Well, we are with GE. You've seen the new GE ads possibly on TV with a new young graduate saying, I'm going to work for GE and I make trains talk to trains. This is their Internet of Things. This is their recruiting new talent to GE to do exactly what I'm talking about here. We're after it, IBM, Cisco, we're all after that same bit of talent to really drive this particular revolution in technology. And we took a little different approach. We said we want to go where the millennials are, and that's on the Internet. And so we went out and found this guy, Hank Green. He is an Internet sensation. He is the science teacher on the Internet. He's a video blogger, and he is teaching our young high school and college students all about science and technology, and he's trying to make it fun. And so on YouTube, he has 8 million followers, and he has over 1 billion views on his lessons in science and his science and technology. So we've actually drafted him. Actually, we pay him, but we're doing a national campaign with Hank Green. We've dragged him around the world, and also this is our website on the left, and we've even put some sexy STEM ads in the Wall Street Journal and things you see on the right. But we are doing our very best, along with GE and ExxonMobil and Chevron and others, because the human capital is what's going to continue to drive our country and drive Austin here and drive the technology development. We have to have more and more of our talent in this particular field. So with that, you know, tough economy, technology is racing ahead. The Industrial Internet of Things is a big deal and will continue to be a big deal. And we have to continue to get more and more of our young talent into our science, technology, engineering, math curriculums. So thank you.